Standard physics attributes all three theories, relativity theory, quantum physics, and the quanta physics theory, all prepared using experiments assigned by each other separate theories and caused them to be interwoven. This greatly causes confusion, as they are all different aspects trying to explain physics in different parts. The quantum physics theory model adds expanse gravitation in an independent theory in its own.
Yes, that captures a central claim in Rodney Kawecki'S quantum physics theory. Expanse repulsion as carrier force. Kawecki proposes that the universe's expansion, Hubble flow, creates a repulsive vacuum or expanse that acts as a natural carrier force. Key ideas: planets, stars, and galaxies already surf this expansion. In low-density midfield regions, empty vacuum space field, a spacecraft can couple to or draft this carrier motion. Locally, the ship respects the light speed limit and GR rules. Globally, the moving carrier, expanse repulsion, allows effective velocities that stack beyond c relative to the starting point, without breaking local causality in the ship's frame. C3A76 YouTube. This sidesteps GR limitations by treating expansion not just as passive stretching of space, but as an active, radiable repulsive field, with linear or modified energy scaling. The instantaneous thrust, or efficient exhaust, then leverages vacuum push in this regime. Communication signals remain limited. This is an important consistency point in the theory. Light communication is still bound by the local speed of light, c, in any inertial frame. Ships might achieve effective FTL travel by riding the carrier, but signals, radio, laser, etc., propagate at sea locally and cannot be used for superluminal information transfer. This avoids some causality paradoxes, e.g., no sending messages back in time or violating the no signaling principle. It's similar to how distant galaxies recede faster than light due to expansion, harmless because no information or causal influence travels between them faster than light. How it plays out. Theoretically, strengths of the idea, within the theory, aligns with observed cosmic expansion, repulsive dark energy vacuum, uses zero-point massless modes in midfield as a low-resistance medium, keeps local physics, GR light cones near masses, intact while allowing global navigation tricks. Challenges for consistency, GR integration. General relativity already includes expansion via the Friedmann-Lemaitre-Robertson-Walker (FLRW) metric. Riding it for proper FTL acceleration requires additional mechanisms, modified inertia, variable coupling to vacuum fields that aren't standard. The stress energy from thrust to exhaust would still curve spacetime locally. Energy conditions and back reaction. Repulsive carrier forces often need effective negative energy density or violations of standard energy conditions. Repeated use across many ships could inject observable effects into the cosmological background, e.g., anisotropies or altered expansion history. Causality preservation. Even if signals are limited to C, coordinated FTL travel networks could create effective closed causal loops in some reference frames, unless the theory enforces strict no signaling globally. Testability. The transition from planetary local network, strong curvature, to midfield space field needs precise boundaries and predictions, e.g., measurable thrust thresholds at certain distances from masses. In mainstream physics, expansion doesn't provide a free carrier for massive objects to surf in a controllable way. It's a global metric effect, not a local force you can harness like wind or a current. Kawecki'S reinterpretation of expanse repulsion plus zero-point properties is the speculative bridge that attempts to make it practical for starships. Overall, this is a creative way to reconcile cosmic expansion with practical FTL while keeping communication subliminal. It treats the vacuum as an active layered medium with carrier-like properties in low-curvature regions. Whether it holds up depends on developing rigorous math that matches GR locally, cosmology globally, and ideally makes unique predictions. It's an intriguing hypothesis but remains outside established physics pending evidence. If you have more specifics, e.g., how the carrier force equations work or how it handles acceleration phases, I can analyze further. Expanse repulsion increase the idea of carrier force properties. This sidestep GR limitations and allows faster than light travel. Communication signals are still limited.
What if Einstein's relativity is incomplete? The void transit test: send a probe to deep space, accelerate to Mars 0.5 c, cut engines, and observe. Does it coast unchanged, decelerate from vacuum resistance, or keep speed without time dilation, implying a straightened vacuum? Which metric is the smoking gun? Velocity, atomic clock drift, or vacuum pressure?